Hola, hola. Today is Unit 13, Day 9. It is Thursday, 5/7. Can't believe it's already May, even though it's freezing outside. Can't take my daily walk, so this is what I look like. The old man from Willy Wonka who doesn't get out of bed. Today, what you're going to need is your Unit 13 note packet, and you're going to need your reference table out. To tables K and L, those are where the common acids and common bases are listed. Just a reminder that your skill check on pH, those 5 or 6 questions, is due by 11:59 tonight. Please make sure you're going back and completing any skill checks that you haven't finished. Just make sure you're doing them. I know they're kind of annoying, but they're quick. And also make sure that you finish the penny cleaning lab. That lab is due on Tuesday, the 12th. It is worth 2 lab grades, and you don't have any lab grades right now. So make sure you do a good job. Make sure you take a picture of yourself with your setup. There's no new skill check today. So you're going to need your notes out to page 14. It might be helpful also to have a colored pencil or a colored pen, just one. I'm going to use red for mine. So today what we're going to do is we're going to talk about something called neutralization. And neutralization is going to carry over into when we do a titration. And you're actually going to be doing a virtual lab on titration. I'm watching a video tomorrow to see what a titration is. The reason we have you do a virtual lab is a titration is a really important experiment to do in chemistry. I'm bummed we can't do it. It's one of my favorites that we do during the year, but we'll explain that tomorrow. So as I said, we're going to focus on something called a neutralization reaction. And you'll notice in the word neutralization is the word neutral. And if you recall from when we were talking about pH, something that is neutral is neither acidic or basic. So it's not an acid and it's not a base. And what that indicates is that my concentration of hydrogen ion is equal to the concentration of hydroxide ion. I don't have more of one than the other. So a neutralization reaction is going to be a chemical reaction. This isn't going to be a mathematical thing. So here's what a neutralization reaction is. It's when you take an acid and you combine it with a base. So those are your reactants, acid plus a base. That is going to yield water, and we're going to write water in a new way today, and I'll show you in a second, plus a salt. Remember, a salt is neutral. It's an electrolyte, but it's not an acid and it's not a base. So a salt is neutral. This is what a neutralization reaction is. You take an acid, you combine a base, and you get water, which is neutral, and salt, which is neutral. Hence neutralization. And to kind of see where this is coming from, remember the ion we associate with an acid is the hydrogen ion. We associate the hydroxide ion with a base. Now, when those combine, H plus OH, you get HOH, which is the exact same thing as H2O, water. And you get the other ions that are left over. There would be an anion here for the acid and a cation up front for the base. Those two would combine to form an ionic compound, which we call a salt. But for today, you want to make sure that you're writing water as HOH. Know that it's still water, we just rewrote it in a different way. It's going to make it really helpful. So neutralization is a special form of a double replacement reaction. Now, we did double replacement reactions back in like Unit 6. So if you recall, a double replacement reaction is when you have a compound, let's say it's compound AB, and you have a different compound, CD. And the two positives switch spaces. Remember, positive ions are written first. So the A and the C do a little do-si-do. Why do I keep writing like that? Here we go. And now we have the C with the B and the A with the D. So that's a double replacement reaction. It's where you have two compounds and the cation, which is the positive ion from the first compound, and the positive ion from the second compound do a little do-si-do. It's like when you guys do square dancing in gym, you switch partners and you end up with two new compounds. In this case, it would be water and a salt. This would be like your acid, this would be a base. So we're going to do a bunch of practice problems, but the easiest way to do this is to write water as HOH. It's going to make it a lot easier when you're trying to predict the products, because that's what we're going to be doing today. And we're going to also balance the salt first. We're going to balance this first, and then it will balance everything else out. So I'm going to give you an example problem right here. Okay, so let's say I have HCl. Here's HCl. That is going to be my acid. And I have sodium hydroxide, NaOH. This is going to be my base. All right. Now, I know this is a neutralization reaction because I have an acid and I have a base, but I need to predict the products. So the first thing you're going to do is you're going to write water first. Now, where does the water come in? Where do I get water from these two things? So you're going to take the H from the acid and the OH from the base. Those are going to combine to form HOH, which is your water. So I'm going to box that in to show kind of where it came from. There's your water, one of your products. Now I need to find out what's left over. I'm going to underline this kind of in blue. So I've got Na and I've got Cl. You need to go onto your reference table and look up the charge of sodium and the charge of chlorine. Don't just smush them together and assume that's the answer. So here's sodium. If you look on your periodic table, sodium has a charge of +1. Chlorine has a charge of -1. If I crisscross those charges, they cancel. So the subscripts stay 1 and 1. So Na and Cl. This is my salt. So I have acid plus base yields water and salt. All right. That's why it helps write the water first, because whatever's left over, make sure you write your positive ion from the base first, and then the negative anion from the acid after. Look up their charges and crisscross. Now we want to check that everything's balanced. So remember, to balance, you need the same number of atoms on the reactant side and the product side. So if I look right here, I have Cl, 1 Cl. I've got 1 Na, 1 Na. Now what's going to be important here, you're going to treat this H as an H and this OH as an OH, meaning I'm going to say I have 1 H on the left, and here's that H, 1 on the right. I have 1 OH on the left and 1 OH on the right. Do not combine these two hydrogens together and try to balance it that way. Treat this as a hydrogen and this as an OH. It can even help you if you would like to put brackets around this and treat it like a polyatomic. That way you're not combining the two H's, it just gets really tricky. So this is actually already balanced, so we don't have to balance it. So that's how you would have a neutralization reaction. It's a double replacement reaction. Notice that the H and the Na basically just switch spots. They did like a little do-si-do. We just do it in a different way for this one. All right, so we're going to do a couple practice problems on the bottom. Now, these were written as word problems. I'm not going to expect you to know where, like, phosphoric acid's formula and calcium hydroxide. However, you can just look on your reference table on table L and K and find those. But I'm just going to write this out for you. It says, write the neutralization reaction between phosphoric acid and calcium hydroxide. So phosphoric acid, you can look on your reference table on table K. Phosphoric acid is H3PO4. So I'm going to write that down first. Plus calcium hydroxide. That is on table L. If you don't know the formulas, we're on table L. You shouldn't know the formulas. We didn't go over how to name. We skipped that part. So I have my acid. I have my base. So now I need to predict my products. So remember, when you do this, you're going to take the H from the acid. Don't bring the subscript with you. Just the H from the acid. I'm going to take the OH from the base, and that is going to become my water, HOH. Now, whatever's left over will become my salt. Only bring the subscripts over if it's part of the polyatomic. Like PO4, for example, that goes all together. You can always put parentheses around it if you like, if it helps you. So I've got Ca and PO4 left over. That's going to become my salt. So I'm going to write Ca and PO4 in parentheses. Now, I can't leave it like this. You need to go on your reference table and look up calcium. It has a charge of +2. If you go to table E, which is your polyatomic table, PO4 has a charge of -3. I'm going to crisscross those to get my formula. So it's Ca3, PO4, the 2 goes outside the parentheses. So notice I didn't take this 3 with me to make the HOH because it's not a polyatomic. I don't drag subscripts. Same thing here, I didn't take that 2. Only because PO4 is treated as 1 unit did I take it. I also made sure I put the calcium first because it's positive and the PO4 second because it's negative. All right, now we're going to balance. And it says to balance the salt first. So remember, acid plus base gives me water, and here's my salt. I have 3 calciums on this side, but I only have 1 here. So I need to put a coefficient out front to balance that. So I'm going to put a 3 out front. All right. Now let's look at the PO4. I have 2 PO4s on this side, but only 1 here. So I need to put a 2 out front. If you balance the salt first, it's going to make it a lot easier to balance the water. So now if I look, I have 6 hydrogens on this side, and I have 6 OHs on this side, but I only have 1 hydrogen here. And remember, you can put parentheses around this OH if it helps, and 1 OH here. So I need to put a 6 out front to balance it. Now, I'm going to be totally honest, guys. You're not going to be having to do this because most of your problems are going to be multiple choice, but you need to understand where it comes from, and you need to understand how to predict the products. So acid plus base yields salt and water. All right, try number 2. I want you to write the neutralization reaction between magnesium hydroxide. I'm going to give you what that formula is. Magnesium hydroxide is MgOH2. That is your base. Hydroxide's a base. Plus hydrochloric acid, which is HCl. And I would like you to predict the products. Predict them and balance it out. You can pause the video if you'd like, and then come back. So remember, the general formula for neutralization is acid plus a base is going to give me water, which we're going to write as HOH. So the H comes from my acid, the OH comes from the base. So I'm going to write HOH, and you can put parentheses if you'd like around the OH part, so when you balance it, it's a little easier. And then whatever's left over becomes my salt. I have Mg and Cl. So the Mg is positive, so it's written first, and you can look on your reference table, on your periodic table to see that, and then Cl. Now I can't just leave it, I gotta look at charges. On your periodic table, Mg is +2, Cl is -1. When I crisscross, I get MgCl2. So I've got acid plus base yields water and a salt. It doesn't matter what order they go in. All right, now we have to balance. We're going to start by balancing the salt first. So I've got 1 magnesium on this side, I have 1 on this side, so that's good. I have 2 chlorine on my product side, but only 1 here, so I need to put a 2 out front. And then once you've balanced the salt, go back and check that the water is balanced. So I've got 2 H's here, but only 1 here. So I'm going to have to put a 2 out front. I have 2 OHs here, and because I just put that 2 out front, I now have 2 here. So that is balanced out. So that is how you would write the neutralization reaction between those acids and bases. Another problem you could see would be the example like number 3. Which equations represent a neutralization reaction? So what you're doing whenever you're asked multiple choice, which one is a neutralization reaction, you need to know the general formula. Acid, which is table K on your reference table, plus a base, table L on your reference table, yields water and a salt. You want to remember that it is a double replacement reaction, right? That do-si-do. So if we look here, there's actually two reactions we can get rid of because they're not double replacements. That would be A and that would be B. A is actually a synthesis reaction where two separate reactants, synthesize or come together to form one product. So this is a synthesis reaction. This is out. Same with B. You've got hydrogen and oxygen gas separately, and they come together to form one product. So that's also synthesis. So we're between C and D. And if you notice, both of them have two compounds, and there's a do-si-do, and get two compounds as products. So they're both double replacements, but remember, neutralization is a specific type of double replacement where you end up with an acid and a base yielding salt and water. So if I look at these two, there's only one that yields water as a product. So this one right here, it has to be my neutralization. And if I look further, HNO3 is nitric acid, which is on table K, and KOH, which is potassium hydroxide, which is on table L. So here's an acid plus a base, yield salt and water. If you look for on these, choice D, these are just salts. There's no acid, there's no base. So I would choose choice C. Now, before you leave, I would like you to try the bottom problem, just predict the products and balance the equation, just as some practice. Okay, so we've got potassium hydroxide, KOH, that's a base. You've got H2SO4, which is your acid. We know that we're going to get water as one product. So I'm going to take out the OH from the base, the H from the acid. Right, that is HOH. And I like to put parentheses around the OH so when I balance it's a little easier. I take the K that's left over and the SO4 that's left over. SO4 is a polyatomic, so you don't have to drop the 4. The only reason I drop the 2 here is because I don't bring subscripts if it's not a polyatomic with me. So I'm going to write K and SO4. And then I'm going to look up their charges. K is +1, SO4 is -2. I crisscross the charges, and there's the formula for my salt, K2SO4. Last thing you got to do, you got to make sure it's balanced. Always start with the salt. So I've got 2 potassiums here and only 1 potassium here, so I'm going to put a 2 out front. I have 1 SO4 and 1 SO4, so that's good. Once I've made sure that the salt is balanced, I can check on the water. I have 2 OHs here. I only have 1 here, so I've got to put a 2 out front. I have 2 hydrogens here, and because I just put that 2 out front here, I have 2 hydrogens. So here's my water, and here's my salt. So that represents a neutralization reaction. Tomorrow, we're going to talk about a titration briefly. You're going to watch a short video clip, and we'll talk about what a titration is. That is a specific laboratory application of this. This is where you'd actually see this in a lab. So please make sure you finish the skill check from yesterday on pH. Make sure that you do your penny cleaning lab. No new skill check tonight. I miss you guys. Hope you're all doing well. Bye.